In this video, I wanted to get you started with some hints on the problems from the textbook that are up for discussion. I'll leave the complete answers up to you. You can discuss these on the discussion board, and I will join in there to help guide your thoughts as well. But if you were unsure where to begin with these, this is a good place to start. Okay, so these problems are from section 5.5. And they're at the end of this section in that critical thinking section. All right, so for exercises 65 to 68, you have two different operations to complete, and then they want you to compare the results and describe it in terms of a property from this section. All right, so for example, in 65, here are the two expressions. So what you want to do is use order of operations to complete each of those and simplify so that you get, like a single number as an answer. And then you're going to compare. So in some cases, perhaps the two answers are equal. In other cases, perhaps they're not. So describing the result in terms of a property means here we're not actually examining the properties that are given in this section. We're exploring other possible properties that could exist. So for example, if one of these problems had been something like 8 minus 5 and 5 minus 8, then you would simplify these to 3 and -3, and then since they're different, they're not equal, then describing this in terms of a property would be looking at what's going on in the original expression. So it looks like the 5 and 8 have switched places, the order's been changed. And what we want to say then is that there is not a commutative property for whatever this operation is. So you have to figure out, do these problems illustrate like the commutative property, associative, distributive, identity inverse, closure, and then whether or not that property exists or doesn't exist. Okay, so for my example here, I would just say that there is no commutative property for subtraction. No commutative property for subtraction. All right, but if I had found that they were equal, then I would say, oh, it looks like there is a commutative property for subtraction. All right, so see what you can do with that. 69, the distributive property specifically applies to a situation where a number is being multiplied by a sum. Right, so in other words, our distributive property would be normally a times b plus c, okay, where there's an addition sign in the parentheses. Using a generic computation of a times b minus c, so generic meaning don't fill in numbers for those variables, just leave them as a, b, and c. So use a generic computation and the distributive property we know. Explain why the distributive property also applies to a number multiplied by a difference. All right, so we're really just asking why is it that we can distribute to a subtraction problem. So for instance, if we had 3 times 4 minus 2, it does work. It's all right to make this 3 times 4 minus 3 times 2. But we haven't talked about why when there's a subtraction sign here instead of an addition sign. All right, so your job is to try to figure out why this works using A, B, and C. And I guess my hint here would just be to think about, we've done this trick before, how can you rewrite a subtraction problem as an addition problem? And if you can show that, then we can just use the normal distributive property over addition to show why that would work. All right, so think about how you could rewrite this as a sum instead. How do we know that the distributive property also applies to a sum or difference in parentheses with more than two terms, something like 5 times 3 plus 7 minus 4? And their hint, one of the properties of addition we studied in this section, will help. All right, so to add on to that, here's my hint. If you have multiple terms in parentheses, think about maybe a way that you could group the things in the middle here so that you just have two things. All right, so can you rewrite this so that this is really 5 times something plus something, right? And then you could discuss, will that always work? So if you had maybe 5 times the quantity 3 plus 7 minus 4 plus 8 plus 2, can you group that? Is there a way to show that the distributive property still applies? The distributive property applies to a situation where a number is being multiplied by a sum or difference. So this only works if we have a number times something in parentheses. Okay. Do operations other than multiplication distribute? So for example, what if we have like a minus b plus c, right? Does this distribute so that you would have like a minus b and a minus c? Does that work? Okay. So in this problem, they're asking, do exponents distribute? Right? So we want to know if we have something like 3 plus 7 squared, is that the same thing as 3 squared plus 7 squared? All right, so in part A, you are just checking those two things. Right, so you're going to work this two ways. You're going to work 3 plus 7 squared using the order of operations, and then you're also going to work out this distributed version and compare those two results and see if those end up being the same or different. And then in part B, we are asking, can we distribute the denominator of a fraction? So same deal. So you want to compute 25 minus 10 divided by 5. So you do that using order of operations. And then 25 over 5 minus 10 over 5. All right, so does that mean we can distribute division like that? And then as far as answering why does that make sense, think about maybe with fractions. We know that like dividing by 5 is the same as multiplying by 1/5. Right, so maybe you could do something with that. In 72, write a description of all of the properties of real numbers that are either used in or illustrated by the following computation, including where and how they are used. Okay, so let me point out the spots where they're used, and then I'll leave it to you to state which properties were used in those cases. All right, so what we have here is essentially just the work written out for adding two fractions with unlike denominators. So all of these steps are just written out so that we can see exactly what's going on behind the scenes and then try to explain all those changes using properties. So the first thing I notice is that 11/4 has been multiplied by 3 over 3. Right? So we are looking for a property, first of all, that explains why 11/4 is the same thing as 3/3 times 11 over 4. All right, so every time you see something being replaced with a new expression, okay, we can put an equal sign between those two things. So we're saying why is 11/4 the same thing as that times 3 over 3. Okay, and think about the value of 3 over 3. That should help as well. The next thing I see is that 19/6 was multiplied by 2 over 2. Okay, so we know 19/6 is the same as 19/6 times 2 over 2. So if you can get part A, you can get part B here. Figure out what property that is. And the third thing I see is right here. Right, we have 33 and 38 are each individually divided by 12. And then those two fractions are being added together, so now it's the sum of 33 and 38 that's being divided by 12. Right, so if you look back, if you're able to figure out the previous problem with the two fractions here in 71, that's a good clue for this one. Okay. Another clue would be to think of this as 1/12 times 33 plus 1/12 times 38, and then that's being replaced with 1/12 times 33 plus 38. Okay, so what property says that that's true? In 73, we know that the real numbers are closed under addition. Explain how we can use this fact to prove that they're also closed under subtraction. Okay, so we know, for example, that any real number, I'm going to call it R1, plus a second real number, R2, always equals another real number, I'll call it R3. Right, so we know that this is true. So how can I use that to explain why subtraction of real numbers? So I'll say like R4 minus R5. Okay. How do I know that that's always going to be a real number? I'll call it R6. Right, so this problem is giving you the hint that this is true, but can you explain this in terms of this other property that we know? All right, so at this point, we've talked about this. I mentioned this earlier in the video. We can do a neat little trick with rewriting subtraction problems as addition problems, so that might be helpful here. We know that the real numbers are closed under multiplication. Does this mean that they're also closed under division? All right, so the definition of closure, in this case, well, we're asking, when you take a real number and divide it by a real number, does that always equal a real number? All right, so you can think through that, maybe try some examples, divide two real numbers and see what kind of answers you get. Okay, and then finally in 75, compare this version of figure 5.8 with the version previously shown in the textbook on page 258. This version below is incorrect. What's wrong with it? So the way they've drawn this sort of implies something that's not actually true about the real numbers. All right, so I would just compare these two, and the difference is really subtle. So see if you can, first of all, notice what the difference is, and then think about what each diagram or figure actually implies. Okay, that's it for these problems, so I will leave this up for discussion on the discussion board, and I will be reading through your responses and jumping in with some comments and questions to try to guide your thoughts in this.